Okay, so in this video, we are going to look at a much superior sorting algorithm called the MergeSort. It is a very fast sorting algorithm compared to bubble sort and selection sort, but it's a little more complicated to understand and to code because it uses recursion. So I've set up a Unit 3 project, and last day we studied an intro to recursion, and hopefully you've practiced recursion. Hopefully it makes a little more sense, and you're starting to get used to thinking recursively. So I've got my Unit 2 project folder open, and I can simply just drag this over. I'm assuming you can do this on a Mac as well. Oh, actually, it looks like I've already done that. Yeah, I forgot that I did it already. So you can actually go to your Unit 2 project and you can just drag any classes that you want over. So I'm going to be using my array methods again. And I'm also going to grab this comparing selection sort and bubble sort. Now that is just the class or the text file. I want to get the actual Java file. So here, comparing selection sort and bubble sort. And I want to bring that over because when I'm done merge sort, I want to compare that to these two sorts. All right, so yeah, we're going to make a new sorting method. So in my array methods, I'm going to make a new method called MergeSort. All right, and this is just going to take in an int array reference, and it's going to swap the elements in such a way that the array is going to be sorted in the end. But it's going to work recursively. Now, we're going to put a pin in this right now and come back to it. In order for us to get this done, in order for us to get the merge sort to work, I need to make a helper method. So I need another method down below that will be used to help us out. So we're going to make a method called merge. And this is the first and kind of the longest step of the merge sort, is to make this merge method. All right, so this method is going to take in an int array reference, a start parameter, a middle parameter, and an end parameter. Okay. Now, this is going to be a fairly large method, and this is not going to be recursive. So the merge method is not going to have recursion, but it is going to be a lot of code. And then we're going to use this recursively in our merge sort method. Okay, hopefully that makes a little sense. If not, when we put everything together, hopefully it makes sense at that point. All right, so what is this merge method? Okay, so I've set up here's the task. I've set up a little array. A drawing of an array here. Now, one thing I should mention, for the merge method, there is a precondition. So there is a condition that ARR must be an array in which the first half is sorted and the second half is sorted, like this. All right, so the first half of your array is sorted like this, 3, 7, 9, 10, 15, and then the other half is sorted, 4, 8, 9, 12, and 16. So in order for the merge method to work, we need to assume this precondition that the first half of the array is sorted and the second half of the array is sorted. Otherwise, the merge method will not work. Okay, so what is the merge method? What are we going to do? Well, in this method, you're going to create a temporary array. Okay, let's call this is ARR. But we're going to make a temporary array that is the same size as ARR. Okay, so in this example, it's 10. Okay. And what you're going to do is you're going to merge these two subarrays. So if we kind of have an imaginary line right here, if we kind of have a border here, we're going to merge these two smaller subarrays into one big sorted array. All right. Now, I said in the method, the merge method here, that um, we're going to have three other parameters: start, middle, and end. And these are just ints. These are just regular ints. So in our example, start is going to be here. Middle is going to be here. And end is going to be here. All right. Okay. So yeah, unfortunately, I can't put middle right like on this imaginary line. You have to choose one of these indices, either index 4 or index 5. And I'm going to choose index 4 as being the middle. Okay, so the algorithm basically works like this. You're going to have two variables, I. So I is going to start at start. All right. And then j is going to start at middle plus 1. Okay, so I and j are going to point to the beginning indexes of each subarray. Now, you're going to basically have a loop that determines which one is smaller, ARR at I, so this number, or ARR at j. Okay, so it turns out ARR at I is smaller. So I'm going to put the 3 up here into the first spot. Oh, just as a little tip here, you're going to want to create another variable x just to keep track of where we are in the temp array. All right. So I just put 3 inside this array. So what you do at this point is you basically say x plus plus. So you add 1 to x. So now x is pointing at 1. Okay, and then whichever element you put in, so in this case we chose an element from the first half, then what you do is you move I up by 1 because we've already done the 3. We've already processed that 3. Okay, but j stays put because we haven't moved the 4 in. All right, so now this loop continues, and now you say, all right, so what's less, ARR at I or ARR at j? Well, this time ARR at j is less, so we're going to put the 4 in here, and then x plus plus, and then j plus plus. Okay, and so then you go to the beginning of the loop and you test again. What's less, ARRI or ARRJ? Well, ARRI is less, so that's a 7. So x plus plus and I plus plus. Okay, and which one's less, 9 or 8? So 8 is going to be less. Okay, so hopefully you get the point now. So this is going to go all the way to the end. So if I just kind of speed this up by not, well, okay, you know what, I'll do it anyway. J goes up to here. Okay, now we have a tie, 9 and 9. So it doesn't matter. I usually choose the one from the first array, so that would be 9. And then x moves up, and I moves up. Okay, now the 9 in the second array is smaller, so that goes here. So then we're going to update x and j. So x is now pointing at the 6, and j is now pointing at the 8. Okay, which one's less? 10 or 12, so 10 is less. Okay, so then update x and j. Okay, you get the idea. Sorry, x and I are going to move up. Okay, 15 or 12. I realize I drew an example where it's always alternating back and forth, but there is a chance where you might have 3 or 4 consecutive numbers from one half that go in before you advance the j value in the other loop. Okay, so in this case 12 goes in, and then we update j. Okay, and then 15 goes in. All right, now something special happens now. So at this point, I plus plus, and so I now kind of crisscrosses middle. All right. So that basically tells us, so when I gets past middle, we know that we're done on the left-hand side. So what we do now is just put all the remaining values from the other half into the array. So just in case, like let's say there were more, if there were more values at the end, and if we're done the first half, so if I is past middle, then you can just have a loop that goes and puts the rest of the values into the temp array. So in this case, we only have one more value, the 16, and then we are done. Okay. Now, the opposite could happen. So it could turn out that the second half of the array wins the race. So maybe J gets past end. Okay, so maybe J gets to be greater than end. And then if that's the case, then we go to the first array and we put all of the remaining elements into the end of temp. Okay, so now what you've done is you've just merged these two sub-arrays, these two half arrays. We've merged them into one array, and this is basically the key idea for the merge sort. Now, there's no recursion needed for this, but what I'm going to do is I'm going to stop here, and I'm going to have you try and write the merge method. So to go back and write the code for the merge method that does just this. So once again, the merge method takes in an array in which the first half is sorted and the second half is sorted. And then for start, middle, and end, again, this is just the first index, this is the last index, and then this is halfway between start and end. Okay, give that a shot, and then we will have a second video kind of explaining the recursive nature to MergeSort.